Okay, so 28b, it actually has several solutions in the interval 0 to 2 pi. It looks deceivingly simple, I think, that equation. Um, so let's work this out. Um, Part of the problem is the fact that it's a cosine 4x in there. But what we do know is that cosine 4x is really a disguised version of a double angle. If I think of it like this, that's really the same thing. And then you can apply, if I think of this as cosine of 2u, where I'm making u equal 2x, right? And then we know that that turns into cos squared u minus sine squared u if you use your double angle formula. So really, this thing here is the same thing as cos squared 2x. Actually, if you leave out those parentheses, that one's just assumed that the whole thing is cosine inside the cosine. And then minus sine squared of 2x. So let me rewrite the original problem here. This is going to turn into, well, actually, let me start with the original. Okay, so if I just leave this cos 2x here, there it is. And then the next term is going to be cos squared 2x minus sine squared 2x. That's what we turn the cos 4x into. Okay, so I'm kind of close, if you look at these two terms, to getting a quadratic where the variable, so to speak, is cos 2x. But this one presents a problem. Although we know that sine 2x is the same thing as 1 minus cos squared of 2x. Right? Because sine squared of whatever plus cosine squared of the same thing has to be 1. So I'm going to rearrange this a little bit more. I'm going to get cos 2x plus cos squared 2x minus 1 minus cos squared 2x equals 0. Okay, so let's simplify this. We'll clean it up a little bit. I'm going to end up with 2 cos squareds. I'm going to end up with 1 positive cos 2x, and then I got a minus 1 here, equals 0. Now this is really a quadratic that's disguised like this, right? And you can factor this one. This turns into 2y and y. And then if I put the minus 1 here and the plus 1 here, that ought to work out. Let's see. That becomes 2y, that becomes negative y, so I get 1y, and then minus 1, and 2y squared. So yeah, that works. So over here, what this really turns into is 2 cos 2x minus 1, and cos 2x plus 1 equals 0. You can kind of see why this problem is deceivingly, it's deceiving. It looks so simple, and then you end up doing all these extra steps in here along the way. So if I solve this one out, either parentheses has to be 0. So in this case, I'm going to get cos 2x. I'm going to skip a couple steps here, but when you simplify it, you get equals a half. So that means if I think of this as a theta, then I get my theta has to be, let's see, when's that a half? That's going to be at pi over 3 or at negative pi over 3 plus 2 pi k plus 2 pi k. And then over here, I'm just going to put k is in the integers. That way I won't forget it. All right. So this means that x has to be pi over 6 plus pi k. Remember, the 2 divides everything. Or negative pi over 6 plus pi k. Then this parentheses, now we got to deal with that guy. So I'm going to get cos 2x equals negative 1. Well, if I think of this as theta, then I get theta equals negative 1, or cos theta equals negative 1 when theta is pi plus 2 pi k, and then that's it. That's the only time. Those are the only times. So if I divide by 2, I get x equals pi over 2 plus pi k. Okay, now we need all the answers that are in this range here, 0 to 2 pi. So you just start plugging in different values of k until you get everything you can possibly get between 0 and 2 pi. So if I plug in, let's say, -1 for k. Well, -1 for k, that's going to make this one negative, and this one negative. So none of those are going to be in my 0 to 2 pi range. So -1's no good. If I plug in 0, I get pi over 6 for that first equation. I get negative pi over 6 for the second one, and I get pi over 2 for the third one. So that's good. If I... Oh, sorry, if I plug in 0 into here, I get pi over 2. Yeah, that's right, that's right. If I plug in 1, then I'm going to get... Let's see, I'll get 7 pi over 6 for the first equation. I'll get 5 pi over 6 for the second equation, and I will get 3 pi over 2 for the third equation, and those are all in my range. Let's see, what happens if I plug in k equals 2? This will be outside of my range because it'll be 2 pi plus more. This one won't be, though. That'll end up being 11 pi over 6, which is just in my range. And then if I plug in 2 for k here, that's out of the range. That'll be over 2 pi. So those aren't in order. I don't really care if you make them in order or not, as long as you have them all. But if you wanted to put them in order from smallest to greatest, it's pi over 6, pi over 2. Let's see, what's next? 5 pi over 6, 7 pi over 6, 3 pi over 2, and 11 pi over 6. Okay, hope that helps.